afternoon, everyone. I'm Sandhya. I'm doing my MA in Applied Electronics in College of Engineering, Gildi, Anna University, Chennai. And my work is smart safety enhancement and parking for vehicles using software-defined IoT network. And I'm guided by my professor, Dr. V. Lakshmi. Let's begin. So let me give a short introduction about my work. Due to the increasing number of population, the increasing number of casualties and road accidents are also increasing due to their carelessness. Also, the number of vehicles increasing causes the increasing complexity of parking systems. The traditional parking systems poses a lot of difficulties. The increasing number of IoT networks increases the entanglement or the complexity of network management. So my objective is to develop a software defined IoT network for controlling the different IoT networks using a software controller, and to develop a smart safety insurance system by checking the helmet and seatbelt lock, and to develop a smart vehicle parking system that provides slots based on Dijkstra's algorithm. And this is the block diagram of my work. Here I consider two IoT networks. The first network is for the smart safety enhancement, that is the helmet and seatbelt check. And the second IoT network is for parking system. These two IoT networks are virtually controlled by the SDN controller. So these are the requirements of my work. First, the hardware requirements and then the software requirements. For hardware, I required a Raspberry Pi controller, Node MCU controller, and the switch servo motor and RFID readers and tag. For softwares, I have used Raspberry Pi OS, PyCharm IDE, Arduino IDE, and Oracle VirtualBox for using the MiniNet tool. In that only I have created the SDN network. So the first part is the safety enhancement system. This is used to indicate whether the drivers have worn the helmet or seat belt. So for this, I have used the Node MCU controllers. Here, the switch is actually the sensor part. The switch is placed in the helmet buckle or the seat belt buckle. And once the seat belt or helmet is worn, the switch indicates the other side controller. And with that, servo motor controls the key control the key enclosure. That is, the key enclosure is closed by an the key is closed by an enclosure when the driver has worn the helmet or seat belt. Then only the servo motor opens the key enclosure, and then only the driver will be allowed to place the key. So this is safety enhancement, and just I have given the working of that. For here, the two parts are here. One is the transmission part, the other is the reception part. This is the hardware setup of my work, and this is the output. Actually, the output of this work is given to the server, and from the server it is received to the other side controller. Next comes the automatic parking system. Here, once the vehicle enters the parking system, the Raspberry Pi identifies it and gives its ID and gives a slot. The slot, for giving the slot and the direction, I have used the Dijkstra shortest path algorithm, and the database is used for identifying the empty slots. And here I have given the workflow. So once the entry of the vehicle is identified, the vehicle ID is given to the vehicle. Dijkstra algorithm is used to give the nearest parking slot. Also, the shortest path direction is given to the vehicle. Once the slot is chosen, based on its availability, the slot is given to the vehicle. The vehicle will be parked in that slot using the directions given by the algorithm. So this is the algorithm flow. Initially, the nodes are chosen. Here, the entry node is the starting node, and the empty available slot will be the end node, and then the shortest path is calculated. The process is repeated for all the vehicles. This is my parking template prototype. Using this only, I have written my code algorithm. So here, the green slots indicates the free slots, red one indicates the booked one, and the corner slots are unused, obviously. The existing parking system, here they have used LED lights to indicate the empty slots and empty slots and the already parked slots. But here we are in my work, we are using the database. So this is the hardware setup of this work. And for this is the parking template I have created in PyCharm IDE. This I have used to implement the Dijkstra's algorithm. Parking template, and here in this one, here the status of the parking and the directions for the vehicle is displayed like this. The output of the Dijkstra's algorithm. Here I have chosen 36 slots.
with that, here I use the dictionary data, and the first one will be the parking node, and next will be the distance from its entry. So there are this is the number of parking slots, and this is the ordered parking slots based on its distance from the entry, and finally the slot is given and the direction for this given slot. And here this is a database. Here according to this distance, the slots are arranged, and availability is given as 1 or 0. This is the vehicle ID, and time about the when the vehicle is entering the parking slot is also noted. And next comes the IoT, SD-IoT network. Here, why I go for IoT is that when the number of IoT networks increases, the complexity will be increased. So, in order to avoid the latency, congestion, and security problems, I'm going for SD-IoT network. So, in SD-IoT network, the control plane and data plane are separated. That is, the data will be traversed in data plane, and in the control plane, only the uh, routing protocols and routing protocols will be placed in the controller. It only decides the data routing. Only it has the rights to take the decision where the data should go. And this is the designed topology. Here I have used the SDN controller as a controller, and two switches, that is for our two IoT networks. The first switch is for smart safety enhancement, and the second switch is for smart parking system. And in that, H1, H2 are two hosts, and H3 and H4 are the other two hosts. The H1 and H2 are used for say smart safety enhancements, and H3 and H4 are used for smart parking system. Though H1 and H2 are the vehicles, H3 and H4 are the parking area. It might be in mall, hospitals, etc. So I have given it deeply. C0 access is SDN controller. S1 and S2 are two switches that routes the data, and there are four hosts here. I have created this network in Mininet environment. It will be in Oracle, and I have used Ubuntu OS. Here, Python language is used to code this. And once the connection is established between all the nodes here using this software, and this is the output of that. And finally, does the proposed system enhance the safety of the driver with helmet check using Node MCU controller? In parking system, the registrar's algorithm is executed and the nearest parking slot is given with the directions to the respective slot. And the database is also maintained with the vehicle ID, its availability, entry time, slots, etc. And SDN network with two switches and four hosts here, and the communication is established and checked. And my future work is to implement the SD-IoT network to manage more number of IoT networks and to assign any application to the SD-IoT network controller. And these are the references I have chosen. And thank you.
We will talk about the relationship between the school manager's authentic leadership behaviors and the teacher's emotional behavior. We prepared this presentation with my MS students, Mehmet Akif Köse. We can continue, please. Okay. First of all, we can talk about a little bit the conceptual framework. Ravi, could you continue, please? Yeah, that's the introduction. Emotions are really essential to personal, professional life because usually we are seeing that Turkey also in the daily effects of the emotions and also the critical impact of the emotions on work. We can say that emotional labor is the widespread in the workplace and was estimated the significant component of the more than 1/3. And there is some conceptual framework in here, but we haven't enough time to say about that. You can change the slides fastly if it's possible. Too many things changed and the emotions also changed in the daytime day. There are some, it's coming to me. Yeah, the emotional labor is conception is the two different forms. This in the beginning, it was the surface acting and the deep acting, one more, the Genie emotions added as a reference to the other dimension. Surface, I think we can define it the changing expression by showing emotions that are not reality filled or suppressing real emotions. It's like wearing a mask, and one employee reluctantly smile while interacting with the rude customers. They act superficially. The deep acting involves the changing an emotion state by trying to feel the emotion on display. It's the real one. And the Genie emotions is the best we can say that we are waiting to for the Genie emotions to workers. We can refer it its expressions consistent with the field emotion in the Genie emotions dimension. It's not necessary to domain the behavior as the surface and the behavior, which is shown as its field. Yeah, we can continue. And authentic leadership, if we want to describe it, it's the defines as a function of self-awareness, sensitivity to others' orientations, and the technical sophistication leading to the synergy of the leadership action. This study considers authentic leadership is four dimensions that are relational transparency, internalized moral perspective, and the balanced processing. The last one is a self-awareness. Yeah, we can continue now. The relationship between authenticity and emotional labor is particularly relevant to leadership research. Authentic leaders are guided by their instructions, values to what suitable for their fellow stakeholders, and which leads them to express more positive emotions such as gratitude and appreciation and the caring towards the over others. Yeah. When we talk about the objectives of this study aims to examine the relationship between the school administration, authentic leadership behaviors, and the teacher's emotional behaviors. We use the model as a model, a relational survey model between the teacher emotional labor behavior and the school administration authentic leadership behavior. Let's talk about our participants. There are 426 volunteer teachers randomly selected. We choose them, and then there are more of them is the female, and more of them is married, and they are usually between the 31 and 40 years old. Yeah, let's continue. Yeah, and the most of them choose their profession voluntary. We can continue, please. And then data collection tools. We use the two different data collection tools. One is for the authentic leadership, and then their reliabilities and the Turkish adaptation is good. Yeah, we can continue. Thank you. Yeah, we can continue. Okay, first of all, before the analysis, we check the skewness and cortices values. The test we use it's the normal distribution, so we use the parametric test. Okay. And when we check the results, we are seeing that the teacher's surface acting is middle, and the deep acting is the high, and the Genie emotions is the very high. It's good for these to teach teachers because we are looking for the Genie emotions. They are when we track the research, if you have a Genie emotions, you are seeing that the too many positive organizational behavior could be better. Yeah, please continue. And the other table for the results, we check the teachers' genders emotional behaviors to genders. And we are seeing that difference between the surface acting and Genie emotions. We can say that the male behavior more than women as a surface acting, and the other side, we are seeing that the women behave genie emotions than male. Yeah. And the other table is we checked teachers professions. Are they choose the teaching as a voluntary or the effect of their families? When we check them, if they if their own recast, we are seeing that deep acting and the genie acting is good. If they choose their professional effect of the family and environment, their surface acting is more. Yeah. And the other table is we are showing the relationship between the authentic leadership's dimensions and the emotional labor dimensions. We have some relationship between them. And the most affected dimension on the authentic leadership on emotional labor is the relational transparency. We can see it in this table. Yeah, if the leader behave the emotional transparency, the teacher's deep acting and the genie emotions behavior is more. Yeah. And we are checking for the discussion and conclusion, and the last we have some suggestions about that. And we are seeing that male teachers have some higher discussions, and yeah, then continue. Okay, it's going now. In surface acting subdimensions, teachers who choose the profession with the influence of the family environment higher level. So we can say that if the candidate of the teachers choose their professions themselves, we will see the genie emotions and deep acting better. So we can do some studies about the male, the high being high or the male deep acting and genie acting. And the choice of the profession is important for the on site. Yeah, we can stop it all. Just we can check our references. I think it's the time is okay. Okay, let's check the references. Okay, there are some suggestions here. These are my references that I used for the studies. And the last page is the text for you. I'm really welcome to together with you. Thank you very much.
I'm presenting a low profile full duplex antenna using T-shaped resonator for V2X communication. In my guide, Dr. M. Shanmugapriya. These are my team members. My aim is to design the antenna for vehicular communication. Then the antenna used in our project is a microstrip antenna. Then the microstrip antenna are chosen for its high quality signal for vehicular wireless network, and it's coupled with its feature like low profile when and its low lightweight and the S of implementations. Then my objective is to achieve high gain and high efficiency. Then transmitter and receiver isolation is 60.8 dB at 5.9 GHz using the series of bias and two L-shaped and stub at either side. In my introductions, nowadays we are using many different types of vehicle. Then it's using many different many different type of antennas. Then the vehicle to everything communicate is rapidly evolving a technology that enable vehicle to exchange information with other vehicle, the infrastructure and pedestrian and even network devices. Then, however, integrating antennas for V2X communication into vehicle presents several challenges. Then the factors impact performance and the consumption, the reduce the range, the increase the interference and the comprise the reliabilities. Then it became possible to mitigate and interference the maintain high quality communication performance. Then antenna ability to operate effectively within the limited space available in the vehicle make then it vehicular platform ranging from compact cars to large vehicles. Then this antenna proposed can be manufactured using standard techniques, ensuring cost effectiveness and scalability for mass productions. This is my literature in V2X communication. First one is DSRC versus LTE V2X Imperial performance analysis of direct vehicular communication technology. Then its frequency range is 5.9 GHz and it's using FR4 substrate. The next one is a dual polarizer high polarization antenna design and a beam steering array enabling full duplex communication for operating over a wide frequency range. Its frequency range is 2.1 to 2.4 GHz and substrate material is using FR4. The next one is a multi-mode resonator fed dual polarizer antenna array with enhanced bandwidth and selectivity. Then its frequency range is 5.9 GHz and it's using FR4 substrate. In my proposal antenna, considered two modes, TM0 and TM1 mode. It's operating to achieve a good impedance at 5.9 GHz, its frequency range. Then both transmitter and receiver ports, the antenna design parameters such as length, width, and patch notch width of the microstrip feed line is denoted WF. Then instated depth is LF are chosen. This is my simulation designs. And first one is step by step. I designed an antenna. This is our parameters. Then first one, this is a simulated results. Then first one is S11 return loss. S11 return loss is how to frequency in our antenna. Then second one is radiation pattern. Radiation pattern is to radiate and out of the energy of the radiate from the antenna. The next one is VSWR. VSWR is voltage standing wave ratio. Simulated antenna have high efficiency since high process allow for the optimization and fine tuning. Then the engineers can analyze the different factors like impedance matching, radiation losses, and manufacturing constraint to improve the overall efficiency shown in the simulated figures. Then this is the flowchart fabricated antennas. First one, start the design and simulate. Next one is get FR4 substrate to import the Gerber file into the systems and open the LPKF circuit board pro and import the images into LPKF. The next one is fit FR4 into the LPKF machines and remove the unwanted part using the fabric colored solutions. And the next one is the design as per requirement. Then assist to testing. Then next noise to get do the first get the FR4. Then next one is to stop the fabrication process. This is an fabrication results. First one is the front view of our antenna. Second one is the back view. The S1 is VNA measurement results, and this two is VNA measurement results. First one is S1 return loss. Second one is VSWR. The fabricated antenna can also achieve a high efficiency when designed and manufacturing carefully. However, real-world fabrication limitations such as material losses, the parasitic effect, or imperfect matching can slightly reduce the overall efficiency compared to simulated antenna figures shown in the fabricated results. Then my conclusions in this project, a novel collinear polarizer SRFD antenna with high transmitter and receiver isolations, then greater than less than 60 dB using the array of wires and two stub resonator. Then the simulator measurement to results confirm the both transmitter and receiver terminals have impedance bandwidth. Then 2.1 percentage at IBW at 5.9 GHz band with a nearly identical radiation pattern measured to peak the realized gain of 7.15 dB. The proposed SRFD FD antenna can be scaled to the 6 GHz as well wave bands. This is my reference.
Today I'm going to share our paper, which is called a stacking ensemble approach for nuclear prediction on dairy cattle. My name is Rayming. I'm from Department of Computer Science in Loughborough University. So it's like the forecasting of the milk yield is a matter of a great concern for dairy community, and it has been shown that global milk demand is expected to grow by 22% between 2018 to 2027. It's important for dairy farmers to understand the essential factors influence the milk production, so they can deploy optimal management strategies, increase milk yield, and reducing their production costs. And in the past, the livestock management relied more on the domain knowledge by the people, and some people start to use mathematical equations to establish the relationship between the features. But with the development of technology, dairy farmers are finding more effective management strategies, like using the intelligent management systems and record their captures of their herd. So this leads to an increase in the availability of farm data. So the artificial intelligence and the machine learning algorithms become a potential tool. So we will apply the machine learning to the dairy farming, because the rich dairy data makes machine learning a potential tool, and machine learning can handle complex and nonlinear relationships among those variables and capture patterns that might be difficult for humans to discover. So the aim of our research is first to identify useful factors for long-term milk yield prediction, and second, to develop a stacking symbol model for long-term yield milk yield prediction, and third is to build baseline model on the conflow data set and compare the performance of various machine learning models. So this is the machine learning pipeline we provide in our study. So based on the conflow data, the data validation and pre-processing will be performed. And after understanding the data distribution and cleaning the data, we will perform the feature selection. And there are 4 different feature selection methods we use, and we take the average of each ranking. And after the pre-processing, we got well cleaning data and split to the training and testing set. And the training set is to train the model, and after getting the training models, and the testing set is used for testing. So finally, the performance of each model will be evaluated and compared. And the data we used in this study is called conflow data, and which is published by the National Institution for Agriculture, Food and Environment in France. And this data set contains 400 reports for individual calls on a wide range of diets and different biological characters, which is ideal for our research purpose. So we will do the data visualization. So the aims we do that is to see the data distribution and balance, and to check if there are any missing or outlier data. So the right side are the histograms for part of features such as cow age, body weight, and dry matter intake in the data set. So it can be seen that most of cow age in the experiment are between 2 and 10 years old, and histogram of body weight, nitrogen intake, and milk yield indicate that these features closely follow a Gaussian distribution, which may simplify the model process and reducing the computational resource required for modeling. And the right down figure shows the body weight versus the milk yield figure, which indicates that milk production increased as the cow age increased for cattle weighing less than 600 kilograms. For cost weight over than 600 kilograms, the milk yield doesn't exhibit a lot of variation. And then we will do the pre-processing. So first we will remove the record which the physiological state is dry. So that means they don't produce milk. And also for the missing data, there are 3 missing values in each of the features: the organic matter intake, ash intake, and milk yield. So these values are replaced by the mean values of each features. And we also need to clean the outliers, and in order to prevent the loss of data available for training, so only those records are removed in which 2 or more features are identified as outliers. And after the whole process, we will do the standardization, and this is for the further steps. And also for feature selection, it's like irrelevant, random, or less discriminative variables can degrade the model standardization, capability, and accuracy. So the 4 different feature selection algorithm we use is shown in the tables. So we can see among all of the features, the action intake shows the lowest ranking among the most of feature selection methods. And this, a part of this, we can see the heat map in the right side. It's like they have the multilinear regression for the, for example, for the organic matter intake and the N intake. So we need to remove features that they have linear regression between each other. So this will improve our model accuracy. And for the model training, after the whole pre-processing, there are only 397 records out of original 44 points, and 9 selected features variables are kept for the model training. And for the data, we randomly split to 94% and 25% for training and holdout validation framework. And linear regression, small vector machine, random forest regression, AdaBoost, and artificial neural networks are used for to train the baseline model. And after we train the baseline model, stacking model based on the 3 best performance models are designed for the stacking symbol model. We can see the right figures. So like the artificial neural network, AdaBoost, and small vector machine are the 3 the weak learners, and the range regression are set to the mental model. So we in this then we compare the different models. So it's like the metrics used to measure the performance of the models include the R-square and mean absolute error and root mean squared error. And the R-squared is less than 1, where values close to 1 indicates that the model captures nearly all of the variation in the outcome of the target. And MAE and RMSE measures the errors. So it's it is the lower the model performs better. So as when we see the figure after feature selection, the overall performance is increased. For example, the R-square value increased from 0.807 to 0.811. And also we deployed deployment of stacking symbol method, and as we see, the R-square value is the best one. It's 0.85, and also the 2 error metrics are the lowest. So which indicates our method is performs better than the traditional machine learning method. And in our paper, a machine learning pipeline is developed and applied to the control data set for predicting milk yield, and also 4 different feature selection models were performed. We used the 9 features of the original 30 features after data preprocessing and feature selection. And also we propose a stacking symbol approach for the milk yield prediction, which achieved the best performance at R-square value to 0.85. And among the factors, we see the ash intake is not an essential factor for milk yield. And also the crude protein and OM intake are the highest are highly correlated to nitrogen and dry matter intake. So we can, for the further research, maybe we can just use one of them to replace other. And for the future, we will try to use the better algorithms to achieve a better accuracy, and also we will use the larger data set to do our research and find more discoveries about the nucleus. And
Yeah, so my topic is to design a disk rotor for all-terrain vehicle using a and weight reduction using a topology optimization. So basically for this, we know that every vehicle or a moving body needs a stopping component that's called as a brake, right? So with this topic, I have used a SS410 material to make a rotor. So previously, what we are doing is that directly we are using a OEM product, that is the original equipment market product, to use it in as a brake rotor. But we have found some gap in using that, and we are bound with some parameters that we have to accommodate the weight as well as the strength of the disc rotor with the OEM itself. We are not getting the desired output what we want as an our design, right? So for that we were processed with designing a new disc rotor with the SS410 one material. And the reason for selection of the SS410 material is that its corrosion resistance, machinability, and availability in the Indian markets. And apart from that, wear resistance and long length availabilities. That is our requirement for the manufacturing point of view is available. So after rigorous studies and comparison of various material, we have decided to select a SS410 material to manufacture a disc rotor for an ATV vehicle. So topology optimization, with the topology optimization, we have rendered the this rotor and taking a reference of the OEM product and made an most optimized this rotor for a ATV buggy as per our convenience, right? So with topology optimization, we will be knowing that how it helps us in reducing the various parameter or getting optimum output what we are required of. So in topology optimization, we opt a safe optimization for getting a most optimized disk as a rotor. We can see from the images that it is an OEM product that comes under a non-optimized disk rotor for our reference. So the prime idea of the safe optimization is to put a material in an area where it is most required and reduce it where it is feasible to do that. Right. So we with this safe optimization, we will be getting a less material consumptions for the manufacturing as well as high strength to weight ratio we are getting. So this yeah, and with all the functional necessities are fulfilling it. So for that, we have assumed some parameters for manufacturing the and doing the calculation work so that how to get the most optimized output. So we will be doing with the parameters with the, like weight of the vehicle and weight of the driver and weight distribution and the height CG height is the most important parameter for designing the disc rotor. And the assumption what we have made is the brake force on the pedal that on the brake pedal and the maximum stopping distance where the vehicle gets from the side time to the where the all four wheel gets locked at that particular distance that comes under the maximum stopping distance. And parameters is like most important parameter is consideration is the pedal ratio that we have taken is 4:1, and the maximum stopping distance is about of 12 feet, that is 3.65 meter. And the maximum speed of a vehicle we consider is that the 48 kilometer per hour, as it's not an is it not a commercial vehicle, as it's a all terrain vehicle. The maximum speed that we can attain on that particular vehicle is for 40 kilometer per hour. So that we consider, and these are the calculations what we have done. So for that we for getting an optimized result, we have calculated the most important parameters such as the operating pressures for the both the tires, that is the front and the rear. And similarly for the clamping forces, we have calculated both the ends, that is the front and rear individually. And for torque also, we have calculated the front and the rear using the dynamic weight of the vehicle and the tire diameters. And the most important thing is that we have used a different tire diameters for front and rears. Now for with calculating with the talks and all, we will be going with the what we can design and effective rotor diameter, that what is beneficial for the vehicle that we are designing for. So after doing all the calculations, the front we have got two different diameters of the disc rotors for the front and the rear. So the front, due to the weight distribution and all, we will be, and we know that during a panic braking or even a normal braking condition, we will the weight transfer from rear to front. That's why we need a larger disc rotor for the front, and we will be getting a size of 5.08 inch. And for similarly for the rear one, we are getting a 2 inch. So after that, we will be calculating the brake force and brake heatings. So after brake heating, we will be getting a stop energy, and rotational energy is the parameter that we need to calculate for getting an design this rotor for ATV vehicles. So what we get as a rotational energy of 425.84 joule. So now we this is the optimized this rotor using a shape optimization topology. With this, what we are getting in optimized this rotor is the optimum heat dissipation, which is one of the most vital parameter for a disc rotor. As we know that during the braking, a large amount of heat generation is generated during the braking in normal or a panic conditions of a vehicle. So we are getting a optimum heat dissipation over there, and weight reduction as compared to the OEM product what we have taken as a reference, and the rotor size as per the optimum requirement, or we can say that the what our requirement that is fully satisfied with that new optimized rotor. And the thickness is also we are getting as per our requirements. And the packaging area, that is most important important thing what we are getting as an output, because a package area means that it totally defines the whole wheel size of a vehicle. If it is required a less package area, so we will be accommodating the whole wheel assembly in a less packing area, and so we will be required a less PCD, pitch circle diameter, that stand for the wheel. So obviously if the size gets reduced, the weight is also get reduced, and we will be getting a better performance from the vehicle. Now we have done an analysis for that but same new optimized rotor, and we will observe that at PCD we are getting a most heat generated, that is about 69.99, or that is approx to about 63 degrees Celsius at the temperature is observed at the PCD. At the contact area of the braking caliper for this rotor, heating dissipation was and we are getting a heat dissipation is achieved when there is a contact between the both the ends of the brake pad, when the pistons applies a force on it. So that is so the design objective was fully satisfied, and we are hence getting a most optimized output as an app. And now if we compare with the weight, the most important parameter is the weight and the strength what we are getting. and we found that we are getting a 26.75% less weight as compared to the OEM product, which directly enhances the performance of the vehicle and getting getting a most valuable output while giving a most optimum braking forces. So this all about the parameters, that all about the optimizations using a topology method. So with this using so we can optimize any I have taken a consideration of ATV vehicle, so we can use this concept to optimize the weight or shape or weight reduction, and using uh, minimal use of the material for any commercial or two-wheeler or any scooters also for the disc rotor. And for I have taken an ATV vehicle because just because of that for nowadays many natural for NDR in India I am talking about. If natural disaster comes, NDRF trains get difficult to access, where the normal or commercial vehicle accessibility is very well is next to impossible. ATV vehicle might get possible to access that particular area, that is about flood prone areas or the areas that are hit by the natural disaster. So it will be a very important ATV vehicle will be become a very important asset for such natural disasters for natural disaster conditions for the teams that are supposed to be rescue. So these are the some of the references that that I have studied or used for doing this paper. So that's all about from my end. Thank you.
Thank you very much, everyone, and thank you for the organization. I'm still here.
Yes, ma'am, we can hear you, please.
Yeah. Yeah, thank you very much for the organization, for this opportunity. Nice to meet you. I'm Bai Hua Li, professor in machine learning and computer vision at Loughborough University, UK. So today I briefly introduce our research in AI, robotics, and machine learning computer vision. So Loughborough University is one of the top 10 universities in the UK, and we have gained a lot wide international collaboration, and also the science engineering topic is at the very front end of the research. Loughborough University is extremely famous by the sports. It's world #1 in sports, and we win the Queen's Anniversary Award 7 times, just the next position to Oxford University. So at computer science department, we mainly have research in the vision, AI, autonomous, and the human-centered system. We also do a lot of research on the network and the system. Basically, it's Internet of Things, and also theoretical computer science. So we collaborate widely with world university, industry, and also the academic. And then so we get a wide range of fundings, and including the national top research funding from the EPSRC and the international collaboration research in the Newton Fund and the UK Innovative Research Council from the UK. Yeah, and also we engage with the European country, European IP7 project, and our central research is around AI, machine learning, robotics, and the autonomous system. So application of our research, we not only do the theoretical, but also highlight the application in wide range. So for example, in agriculture, environment control, monitoring, healthcare, and smart manufacturing industry 4.0, sports, and the security surveillance, and also the finance risk assessment. So I gave some of the examples of our current research. So for this one is AI, robotics, and the autonomous system. We theoretical we focus on the bio-inspired. That means not only from data, learning from human beings. Yeah. And also we apply this theory into the AUV and the autonomous ground, area, and also underwater vehicles, and also agriculture, industry, robotics, human computer or robot interaction, and service robot sensor-based situation assessment. All right, so you can see from the image, you can understand, and then this is the driver's vehicle for the tracking and understand human gestures. And then the sensor will use not only the RGB, but also the thermal camera. So for privacy and night vision, and especially for animal and human, yeah. And then so tracking people and understanding the behavior behind. We also do a lot the human computer interaction and using robotics, and then and also the top-down view from this one is a fisheye camera to monitoring the public space, and also the care home. So I will quit. And this is a project funded by the Innovative UK. LabRA is world leading in sports science and sports technology. So we use the computer vision technology, try to understand the football match, for example, and then the player position and their action, shooting the goal, and also assessment on their performance. So you can imagine from this one, and this technology can also apply to other sports. And also another project is about AI used for autonomous agriculture robot for precision spray. Autonomous vehicle has been widely developed, and for the urban on road like Google and this system. But agriculture is largely behind, and also underwater system is very largely behind. So using the autonomous vehicle technology, we would like in this project develop accurate pesticide spray for trees and orchard. Currently, the human operator has to drive the vehicle into the orchard and spray, and it's not accurate. The chemical will spray in air and soil and anywhere to cause pollution and also very danger for health risk. Yeah. So in this project, we want to use develop the autonomous vehicle system to automatically navigate within the fruit orchard. So for example, we need to deal with collision avoidance, tree and path planning, tree crop identification, so that the spray can only focus on the area, the region which is needed. Yeah, and another project is funded by Newton Fund and in collaboration with industry and academic in China. So so in this project, the contribution, the main idea is we use AI and also Internet of Things to monitoring the air pollutant, and also link to the carbon trading platform. So from this one, you can see there are 3 layers. The bottom layer is Internet of Things layer, use different 3 sensor networks. And then the middle layer is the cloud layer, and then do the machine learning, data processing, and the predictive models. And then top layer is application. And then based on the prediction on the air pollutant, and then can help the personal traveling and also people with personal health or breath problem. And also the very novel aspect is linked to the carbon trading, because carbon is kind of product. And then if an industry or company, they spend more or produce more pollution, they need to buy the credit. And how to measure the carbon generated from industry or from particular region or company, and then it's still an open problem. Using this system, it can help. So our research has been widely reported by a number of media. So this is a report from the New Scientist. and to highlight the importance of air pollutant, air pollution impact. We also work on the robotic side. So, for example, this is the sandwich production line, and currently they just use a laser sensor, and then can only do very simple tasks like orientate the bread. And what we develop in this one is using the low-cost RGBD sensors, and then to identify a wide range of food ingredient, and then to better optimize the production line, reduce the cost, and then use the real-time robotic vision system. So as you can see, and then currently there's still labor intensive, and then now our robot already work online along with people. So this is the robot hand, and then we develop a vision system, and then the robot can very accurately locate the different object, pick up, and then assembly the sandwich. Yeah, the production line is very noisy and not ideal, and so this is very challenge. And then this project already won several awards in the UK. Made in the UK, this biggest award, biggest venue in the UK, and we are shortlisted. And we also win the award for innovation award in the East Midland, and also the Made in the UK Midland Award. Yeah. Another project we use AI, deep learning, and the image processing technique is for the greenhouse. Yeah, greenhouse, and then this is funded by the UKRI Research and Innovation Research Council. It's to help generate the safe and effective herbicide, and using the AI inspector. So we use AI and then computer vision technology to understand how the effect, automatically assess how the effect of the herbicide, and also detect any symptoms of the problem. So this will reduce human workload and then make it more objective rather than suffer from subject errors. So currently we just win another very large project is self-learning digital twin for land management. So global warming is a risk and facing for all of us. And the agriculture contributes 11% of the UK total emission, and then in this 11%, livestock and the peatland is the main contributor. So the aim of our project we propose is to reduce emission from the livestock and also reduce emission from the land use, for example, the peatland. How can we restore the peatland into normal use, into a good one? So that is a global warming and the greenhouse emission is the challenge facing to every country and every people, and is urgent. I think Ruiming, the talk given by Ruiming from Loughborough University about milk production and milk production prediction from the cow. That's the initial research. We'll extend this research to next from the link the productivity and also animal health and also the greenhouse emission together. So we, of course, at farm, they want a good productivity and money return. And then for the whole people, our generation, we want also environment benefit. Yeah, we need to deal with this balance. So in our research, we don't only do the deep learning on desktop. You know, the deep learning is a huge hammer currently. So a lot of challenge problems, but a lot of the algorithm only on the desktop won't generate the real world impact. Our research aim to generate real world impact. So we develop the AI on edge Yeah, for example, using the Jackson board embedded systems, Jackson Nano, and also the most state of art, yeah, and hardware system and Raspberry Pi. So we not only focus on the accuracy, but also focus on low energy cost and efficiency, speed. Yeah, and then so this is our research. You see, has been reported widely from wide range, and this is a BBC report, and we visit our research lab, robotics lab, and yeah, so look at our research. So that is very good. And then lastly, thank you very much and give me this opportunity. Nice to meet you.